All right. Let's talk data science. So one of the first things before we jump into the presentation is I wrote a list of questions here just for people to think about while we're talking about data science. Like, how often do you want to have meetings like this? Are any of these topics something maybe you guys would want to teach something about in the future? Because I don't necessarily want to be the one teaching every week or month or however often we do this. And so yeah, just think about some of these things. Okay, so yeah, I didn't introduce myself when we were going around. For those of you who haven't met me, my name is Cody Nault. I do, so my academic background was mathematics and computer science, and I did do a lot of focus on artificial intelligence, machine learning academically. And then for my job, I work at an investment accounting or investment consulting firm, which is why I'm familiar with your work. And I work there as a programmer, and I do data analytics and stuff. But you know, there's a lot of stuff that I would like to branch out more into and stuff that I've been kind of studying a lot of things as a hobby, kind of taking it a step further. So let's talk data science, guys. So, of course, we got to start with the definition. So, a lot of times people don't really think about what data science, you know, they kind of say that it's synonymous with like analytics or machine learning or something, but really, if we kind of look at the intersection of these different fields, you know, we have the computer science for the sake of computer science, and where it intersects with domains, that's where all our software developers live, is we're writing machine code to solve real world problems, right? Well, when we combine that with math and statistics, that's what actually really creates data science. So, so there's just a little bit there, and that's kind of one of the reasons why I wanted to invite not just programmers, because most of the time, you know, data science groups and stuff, they get really focused on inviting all the programmers in there. Yeah, I want the programmers, but I also want the people with that work in public health and just deal with the public health data and stuff, because I feel like the domain knowledge part of this is often overlooked. And so I want to make this topic accessible to the people that aren't necessarily programmers, but also also appeal to the programmers. So there is going to be a lot of nerd talk, but you know, if there's something that I keep saying a lot and you're not familiar with, speak up and ask me to clarify, because you know, sometimes I may start talking about something and not even catch that half the room doesn't realize what I'm talking about. So you know, maybe good to.
I think it's just gonna be me, so I'll just take notes and like email you.
No, you'd be surprised. So, all right. So, data science is a buzzword, along with all these other fun buzzwords. So, let's first make sure that we are all using the same definition. There's no right definition for a buzzword, in my opinion, but at least let's use the same definitions when we're talking here, so we all know what we're talking about. So, I just described data science as a field, as the the intersection of domain knowledge, statistics, and computer science. Machine learning is really the set of algorithms that allow the computer to take a data set and improve predictive capacity. Artificial intelligence is even broader than that. It does, so machine learning really is a specific type of artificial intelligence algorithm, because artificial intelligence is really just anything that kind of solves problems in intelligent ways, really. I mean, there's a lot of different definitions for artificial intelligence, but it's, you know, not really that useful. So I don't really like the term artificial intelligence that much. We throw it around a lot. You know, I say I focused on artificial intelligence. I've taken classes in artificial intelligence, but it's like, but you watch Terminator and that's like a completely different definition, right? You know, so Skynet, yeah. That's what everybody thinks. So that, okay. Big data is one of the other areas that, a lot of times gets, people say are synonymous with data science. Not necessarily, because I think of data science as the interpretation of the data, and the process of dealing with data. It doesn't necessarily have to be terabytes of data. That's really what big data is focused on. It's kind of a piece of data science, along with data mining, analytics. Those are just ways of extracting meaning from data. And then deep learning, that's the interest. That's a whole interesting field where it's essentially machine learning, but it takes things a whole step further in terms of trying to derive meaning. And I'm not really going to get into deep learning systems today. So let's talk about the hierarchy of needs of a data scientist. So this is what we were just chatting about. When you go on, Udemy or whatever, and you take a machine learning course, you're probably learning this piece. And they're like, this is data science. Meanwhile, somebody has to go do all of this stuff. But like I said, this isn't the sexy stuff. So if you're working for a small company as a data scientist, you have to do all of this. So you're going to have to go and integrate with, the actual collection process. You're going to have to take that data. You're going to have to restructure it, prepare it, label it, go through, and then you're going to have to apply your algorithms, and then you're going to have to go and do a bunch of research to try to get, to try to take your predictions to another level. And that's how it is for a small company. But as the company gets bigger, each one of these layers gets broken apart, and so software developers get to deal with this. I'm not going to go program something that goes and deals with connecting to 10,000 different sensors and uploading real-time data into. So, that's not really a data interpretation problem. That's just a programming problem. And so that's why collection is for those developers, the peons. Yeah. And I'm going to be guilty of exactly what he was talking about, because I'm going to be demoing some data where it's already collected and cleaned and prepped and separated and stuff. And so we're just going to do this section. So, yep, we're going to do exactly what he said. But, we can talk about all those on a later day. So who's hiring the data scientists right now?
Lithia's hiring one.
Yeah, well, they added to that one right there. So they're industry. Technology, healthcare only accounts for 2% right now, so you're a minority. I'm in the 16% over here.
It's amazing that in healthcare, you're one of the few data scientists.
I'm trying to bring it.
Yeah.
Growing field. I could talk about it for a long time.
There's all sorts of opportunities in it, like that, and that's. I feel like medicine and healthcare and stuff, we're missing a ton of stuff that we could be doing in data science.
If you think of healthcare and technology, it's 20 years behind every other industry.
I've heard a little bit about that.
Yeah, and this is kind of taking a look at what these different industries are doing with stuff. In the healthcare industry, they can do disease prevention and medication effectiveness studies and stuaf.
So I have a question about the healthcare, because they're actually pushing a lot into AI, visual recognition, with radiological imaging and stuff like that. So it surprises me that it's 2%.
Yeah.
Well, you have
The biggest areas is visual recognition.
you have the people doing the super crazy cutting edge stuff that are always
I'll get to that question in a second.
Oh.
Oh.
No.
Sorry.
No,
You're fine.
Oh. But under that, what I found is that with a lot of industries, you have the bulk of it is super reactive, and then the people actually working on what eventually gets built into industry is, they're like these little enclaves of people who really have a very hard time connecting that initial step. It's like when people talked about graphene being the next big thing, and then, you know, I was at like a CES and talking to somebody who actually produced graphene, like the raw material, and I was like, oh, you must be getting like your doors beaten down for people wanting to like implement this in creative ways or whatever, and invent new, you know, technologies and just use it because it's so amazing. She's like, surprisingly, no. Apparently, people don't know how to develop new products around new materials. Like, it's very difficult to connect those worlds together.
So what are the questions that are coming in over there?
So
I'm guessing there's concern over blurriness.
yes. So
Okay.
the question-
Sorry about that. There's going to be a higher quality video posted later.
So the
I
question
I apologize.
Yeah. It was just a general question of like, sorry. Can you announce the elements on each slide
Okay.
as you're talking them through? And
Okay.
also Cairn Allport Concierge with Rogue Tech Hub.
Well, this is what I
Yeah.
was saying.
Okay.
It
Is that it? Okay.
Could
Yeah,
you still-
I'll take care of that. Yeah, from all the slides from now on, I'll
Could
verbalize them.
you potentially join the meeting and then just share your? Is there a way for two people to share at the same time?
I'm not going to deal with that right now. We'll deal with that later.
Process improvement, that's the plus delta part of this meeting.
Yep.
Key learning.
It's like with data science,
Okay.
the feedback loop.
Yeah. Okay.
Learning.
And we'll have time for questions at the end too. And so like if we got stories or stuff like that, we're gonna run out of time really fast if we have like I can answer short stuff too, but like while we're going. But so tools, we talked about a little bit. Scikit-learn. There's like TensorFlow. We're gonna talk about KNIME, PyTorch. Hey, it's funny because this isn't anywhere near all the tools out there. There's a lot more tools out there. And I'm not even gonna, this is just supposed to be an overwhelming list of just like, over 100 different tools in different industries that are used for data analysis, and like, it's ridiculous. But we're not gonna talk about that. So, yeah. So this is my secret. This is the secret machine learning cheat sheet. So I feel like a lot of the guys when they they learn machine learning, it's like they're proud of how much work they put into it, trying to understand it all and stuff. And so, they don't want everybody to know that there's a flow chart that you can use to determine what algorithm to use. So it's kind of like how IT guys, when you get into IT, the last thing you want to tell people is that you just go on to Google and search up every error codes. Like yeah, what's up?
You be able to share this all later?
Yeah, and if you just type in machine learning cheat sheet too,
Oh, cool.
well, we're actually going to post this video, so.
We can send out the PowerPoint too.
Yeah. But yeah, so like this one kind of breaks the problems into a few different categories. Essentially, the first questions we ask are, how many samples are we dealing with? Do you have less than 50 samples? Then go get more data. You're not ready for this. Like, are you trying to predict something, like a category? Are you trying to classify something? If yes, then we come over here and say, do you have stuff that's already labeled? So if you have things that are labeled, like a bunch of MRIs, and this one says cancer, this person died of cancer, this one didn't, like that's labeled data. And so if you have that labeled data, you can come up here and go into the classification world, which is also called supervised learning. And so there's all sorts of different types of algorithms that you can deal with that sort of problem. If you don't have your labels, if you just have a bunch of data and you have no idea what the relationships are, like what the actual things in common are, you can go do a process called clustering. And that's what these algorithms are for. If you're not trying to predict a category, if you actually are trying to find a quantity, like we're going to be doing later, we're actually going to try to guess what the price of a house is. That is a regression problem, and if you took statistics, you probably learned about your least squares, linear regression stuff, and then you learned how to do it in Excel and you forgot how it worked. That's kind of what this is based off of. but it takes it all to a whole new level. And then there's also dimensionality reduction stuff. I'm not going to talk about that today. So one important concept to think about when we're talking about data is every piece of information, every field that you have about the data is a dimension. So if we have like temperature, that is one dimension. And then we could, we may have like sales of ice cream or something that corresponds to temperature. And so the typical linear regression approach that you would have learned in your stats classes or whatever is, how do you stick a line in there? And then you have that line to help you predict stuff. But the thing is, though, is just like temperature is a dimension, what if we added another dimension? What if we added weight? And like, let's say, we're talking about cars. If we have weight and horsepower as two separate dimensions, you'll see that as weight goes down, the fuel efficiency goes up. So lighter cars are more fuel efficient. But also as horsepower goes up, things become less fuel efficient. And so you can actually graph these planes inside the data to describe multi-dimensional data, right? Well, what about when you have 3 or 4 or 5 parameters? Well, we can no longer visualize it because now we're talking about hyperdimensional space and we can't deal with that. We can try to do like maybe 4 by adding in colors or, just something like that, add in time, make it change or something.
Smoking this weed maybe.
Yeah, do enough drugs, it helps. But ultimately, we get stuck trying to comprehend hyperdimensional data. And so a lot of times when we're discussing algorithms, we discuss them within the context of 1 or 2 dimensions. And then we just say, like, trust me, it works for the rest, like sort of thing. Let the math guys prove that it works for hyperdimensions. But this is an important concept, though, because a lot of, thinking about things in terms of where they exist in space is really about how we compare stuff. That's how we compare things. And so there's a significant number of our machine learning processes that involve finding a hyperplane, which is essentially, this surface in whatever space we're talking about. And so we want to find those hyperplanes. In regression, this is the plane that defines the prediction. In like classification, though, like let's say you have a bunch of data and some are, like cancer, like you're trying to predict cancer or something, and it's binary, either they had it or they didn't. Well, you may want to try to find the hyperplane that divides the sets. So that's kind of, there's a very visual component to this. And I really want to get that across. And so one algorithm so I'm going to talk about one algorithm for classification's sake, the kth nearest neighbor algorithm. So this is a really simple algorithm that takes a ton of memory, but because it essentially requires you to save every single result that you have. If you have tons and tons of data, you got to just compare. You got to plot it all out, and then if you have some new value, you stick it in there, and you say, which ones are the closest? And then how were they classified? Did they have cancer or did they not have cancer? And the ones that have the 2 closer one, it's closer to the ones that had cancer than the ones that didn't. We're going to predict that this new one has cancer. Like that's how the kth nearest neighbor algorithm works. And ultimately, it should, for classification, it should be your benchmark. Everything that you're working on, you should probably be comparing to this because this works fantastic. It's incredibly stupid. There's really no magic to it. This is, it's just surprising. It's funny how like a lot of times people will rig up these elaborate deep learning systems to try to extract like information, like, oh, maybe these parameters are related, and they try to draw correlations between them. And it's like, but if you just plot it all out and find what's the most similar, that's really how most of medicine works. It's like when a doctor looks at somebody, it's like, who does this look the most like? That's what's going on in the doctor's brain. He's doing a mental K nearest neighbor problem in his head. And it's a slight modification to do what like realtors do in real life. When a realtor says, how do I value this price? Or how do I value this house? They go, what are the houses nearby that are similar? And average the price. Like, it's a slight modification to turn the kth nearest neighbor algorithm into a regression problem, because he or she is producing a price, an actual quantity, instead of a classification in that case. So this is fun. So when we have these problems, we are trying to minimize the error. And one easy way to describe this is like, look at how this plane fits in here. And you see all like the distances from here, from all the points to the plane. If you add those all up, that's going to be some error value. The best plane that's going to fit in this is the one that has the lowest total sum error, right? So you have you have this basically tons and tons of equations, or that you're trying to, or values that you're trying to sum up. And you just want to find the optimal value. And sometimes if you are like looking for an optimal value and you plot out like how good of a solution it is as you adjust each of your parameters to a problem, you'll find that like some solutions don't work at all, and then like some work really good. And if you plot it all out visually, you'll find that like there's certain problems that have peaks, and those may be like optimal points in the data that we want to get to. So the way that a lot of these algorithms will work is through a process called gradient descent, or gradient ascent in this case, where we start here, and where we basically check a value, and then we make an adjustment to see what the slope is in each direction. And it goes, okay, well, it looks like there's some distance to go this way. And so eventually it can actually climb up. Actually, this is gradient. I think it started here. This is looking for the valley. So basically it's looking at the steepness, and it's trying to move down to a resting place, right? So in this case, this would be an optimal solution. This would be an optimal solution. This one actually is more optimal, but using this process of gradient descent, we don't really know what the whole problem space looks like. You kind of only get to look down, and you kind of know which way the slope is, and you kind of have to make decisions. You can just keep walking up, or keep walking downhill, and eventually you'll get to a pretty good solution. And so this is a gradient descent problem. And then there's modifications of it, like stochastic gradient descent. In this case, they started from a similar spot. But a lot of times in stochastic gradient descent, what they'll do is add a little randomness in there, a little crazy. So you'll see it doesn't do straight lines towards the solution. It maybe tries a bunch of random spots around it, and it may find kind of a weird path. But because it's not just walking in a straight line, like it's not always going downhill. Sometimes it'll go uphill if it sees like an area with a different slope. So that's, it's kind of hard to understand what's going on here visually, because now we're talking a couple degrees separation away from the data itself. Like this isn't the actual data that we're visualizing. This is the success of the parameters we're trying to optimize to produce that data. And it's kind of technical, but it's but essentially just recognize that gradient descent, or just getting continuous steps closer, is how we solve a lot of our machine learning problems. When we're looking for our path to go towards a solution, it looks at the slope, and if we have data that is, like, let's say this is price or something like that, but it's only like in a certain range. Most of that whole space in which it's searching is like really condensed, and so it'll sometimes take less optimal routes because the actual parameter that the field that we're trying to analyze is not normally distributed or not equally distributed. And so what we can do is by changing our parameters so they get more equally distributed, we can essentially take this problem, stretch it out so it's nice and even, and then the gradient descent problems can find solutions faster. And I'll talk a little bit more about normalization. I'm running over a ton of concepts here. I'm going to kind of be bombarding you with concepts just because I'm going to be reusing this terminology later. And so the other thing, besides trying to solve your particular algorithm, like if you have some line that you're trying to find that the best fit for, like let's say you're trying to fit a plane into some data, and you keep adjusting it and you keep adjusting it, and you can't seem to find a sweet spot. Well, maybe it's because you're making too big of adjustments. Maybe you're missing, maybe you go, oh, you know what? My plane is too high. I need to go down. You adjust it. Oh, now it's too low. I need to, and so what can happen is you end up with these you end up bouncing around the solution. But if you only make tiny movements, sometimes it takes forever to find a solution. And then the other, and it's possible with tiny movements you'll actually find a less optimal solution. So there's all sorts of stuff you have to deal with when you're dealing with the data. And so this is why a lot of times in machine learning they don't teach that you should actually have, they teach, you should have a training set and you should have a test set. This is like what they normally tell you to do. But ultimately, if you don't know what your best learning rate is for your problem or something, you should actually have a validation set inside of your training set that you're actually moving through. So that way you can actually, so you train your algorithm on this, and then validate it against this, and then optimize your learning rate. But because you actually your algorithm has now been aware of that this testing data, this validation data, it's really not right to measure the performance of your algorithm by it because you actually tuned your algorithm using it. So you actually need to have a separate test set of data that you test your final learned model against. And this is kind of describing the process where you have your data, you evaluate it, you adjust some variables until it looks pretty good, and then you run it against the validation data. You evaluate it, you adjust your variables like your learning rates or whatever, and then you come back and you relearn or you retrain. And then finally, when you're all done with that and the validation data is all optimized, that's when you go into testing. I'm not doing this today. I'm just saying, in real life, that's what I would want to do. So I'm going to stop talking and just do something. So the data set that I'm going to be doing a demo with is on Kaggle. For those of you who aren't familiar with, is anybody even familiar with Kaggle here? 1, 2, 3. Okay, 3 people. All right, so Kaggle is, if you're wanting to get some practice doing doing data analysis, Kaggle is awesome. Kaggle is a site that that companies can post their data sets to. So they can go and do all their normalize, they can do the data prep, do all that dirty work that none of us like to do. And then they post it up they post it up onto Kaggle, and sometimes they'll offer cash rewards. Sometimes the winner gets a job. Like, there's a lot of companies that recruit out of Kaggle. And Kaggle's actually owned by Google now. Yeah. And, but it's actually a great resource, and there's a number of different competitions that are just open all the time for you to go practice with. This is one of them. I didn't want to do a live competition just for demonstration purposes, but like, go check it out. One of the easiest data sets you can try to learn on is like the Titanic data set. They have a log of everybody who was riding on the Titanic, like the manifest, and they have a label as to whether or not they died. And you have to write an algorithm that can determine what, like, basically it can look at things like whether, like details about the person or their seed or whatever, and try to predict whether or not they lived or died. I mean, I'll save you some time. If you were a guy or poor, you probably died. But it's pretty fun, and that's it's a good way to, yeah. Yeah, the whole women and children first thing, yeah, you were screwed if you were a guy on the Titanic. Yeah, so that's a fun one because there's some parameters that are very obvious predictors, and so it's kind of fun to test when you're trying to figure out like how a learning algorithm works, to just make to see if your learning algorithm finds that predictor, or that field as one of the biggest predictors. So this data set I thought would be a little more fun because it's it's an industry problem. We get to try to guess how much a house is going to sell for. So we go on here, you got to register, and then you can go on, and then they have all of this stuff already done for you. They have test data, they have training data, they have a description of the data. Essentially, I already downloaded these files. If we take a look at the training data, we have all sorts of fields that they kept track of. They did all this amazing data collection for us, so we don't have to. They have things like lot area, and one thing I'm gonna do is I'm gonna just not even bother with like trying to classify like all these fields. I'm just gonna look at these numeric ones because I'm in a hurry, and like they have like somebody gave it a quality rating, and then the year built, and just all sorts of stuff. Number of bedrooms, square footage, bunch of junk. And then finally they have sale price. So this was how much this particular one sold for. When we have a test set, then they gave us this test set that we're actually like competing on. It has similar data, but these are all ones that we had that aren't in the training set. But there's no sale price. That's our job. We're going to fill in a sale price column. All right, let's do it. We're going to predict the prices. So, first thing I'm going to do, and then their actual like sample submission. They just have an example of what the end result should look like, and it's just they want us to take the field number, this ID number, so 1461, and they just want us to tell them what the sale price is. All right. So let's do this. I'm going to start. So the KNIME is an awesome program for doing like rapid bathroom? Yep. So this is KNIME is a great program for doing like rapid visual prototyping of your of your machine learning stuff. Or just not even machine learning, just any data analysis. It's really easy to just do this, and you don't even really have to know programming. It's all visual, which is kind of awesome. So you'll see what I'm talking about. So essentially, our first job is we got to get the data into KNIME somehow. It's in a CSV, comma separated value. So we're just going to read it. And then we're going to read it from, not that one.
TikTok.
Yeah, I was analyzing my TikTok views. So we're going to train, take the data, and I think it's all standard delimiters. Let's double check. Let's execute this. It ran. Look at the file table. Hey, look, there's all our data. I'm going to leave these row IDs at, I'm not going to, there is no row header. Let's try that again. Oops. Okay, anyway, so we got the data. Now we're trying to predict a value, right? Let's go back to our slide earlier. Okay. Do we have more than 50 samples? Yeah, there was a lot more than 50 in there. Are we trying to predict a category? No. We want a quantity. Okay? So we're going to take this and we're going to go into this regression blob. There's a whole bunch of different types of regression we can do. But you really don't even have to be an expert. I'm just going to show you what you can do if you have no idea what you're doing.
Perfect.
Regression. I literally, oops, you got to spell it right. You can be like, oh, look.
Start from analytics.
There's all sorts of built-in regression systems in here. Like, you don't even have to know what a gradient-boosted tree learner is.
Just throw it in.
There's one. We know it does regression. We're trying to predict quantities. Let's try it. Gradient-boosted tree learner. So we take this, we take our data, and we feed it into there. But I just broke my rule that I said earlier.
Just
We need
That's Factorio, but
we need to separate our test data, right? Because we need to have training data and then testing data for our, to basically know if this thing's doing good or not. We want to be able to evaluate it. We got to evaluate it on data that's never seen before, right? That has solutions. So first thing we got to do is, I can't spell. We got to partition the data. We're going to partition it. All right.
if anyone wants, so bathrooms, first door on the left if you need, we have water,
Oh, yeah.
if anyone needs
Stuff
water.
in there.
Garbage can's now lined.
Thanks.
Garbage can.
Okay. So I'm going to do relative. This is, what is the size of the first partition? So basically the data that comes out of the CSV, what comes out of this? I want 70% of the data to come out of there, because that's a nice number. Let's do that. 70. All right, so and we're going to just have it take random ones. We're going to random sample it, just in case there's some sort of bias in the ordering or something. We don't want to like screw with that stuff, so do a random sample. Take that out, throw it in your learner.
I hope so.
What?
Is it actually random?
We don't know if 9 is lying or not.
It's pseudo-random.
It's seeded. Yeah, it's all pseudo random. You can make your own random number generator.
Build your own RNG.
But
Absolutely distracting.
okay, so now that we have this, we can execute, and we can actually look at the first data set. It got IDs 1. Wait a second.
It's not random.
Well, it was missing 4.
Oh, it was random. It's just weird that,
Just got like the first.
yeah, apparently the first 3 went into the first one. That threw me off. Okay. I guess sometimes you flip a coin and it flips heads 3 times in a row. So, yeah. So we got our random data coming out, and we're going to feed it into this learner. Now the learner, we have to tell the learner what fields are you going to look at. So I'm going to first get rid of all of these, and a lot of these fields are, they're strings. And so like, for instance, one that would be really good to know is like neighborhood. That would be a really good one to know. We could probably do some analysis and like separate the field, like separate all the neighborhoods into separate fields and then analyze those and do all that. But I'm gonna try to produce something in the next 10 minutes. So I'm not gonna normalize any of the string fields. I am going to just take the numbers. I'm going to say, oh, you know what? Whatever class it is, I care about that. The lot area, I want those. Yeah, that's cool. How about overall condition rating, some number, the year that it was built? That's relevant. Year it was remodeled, why not? I'm just going to take all these numbers. Can I shift on this? There's some more integers. This is a terrible way to do a machine learning algorithm, by the way. Like you would not like do this as your like final solution. But I'm trying to point out that there is a separate stage of development that is less polished. That there's a exploratory stage of data analysis.
Why is this worse?
Why is this worse? I'm saying that like you would want to go through each of these parameters, determine what they mean, normalize them, and then like into forms that are actually more suited for the learner. But I am in exploratory phase. I just want to see, can you predict anything? Like what, if I do as little work as possible, how good is this learner gonna solve my problem?
When we were working with the car data set, we determined that year actually wasn't a great like integer value to work with, that it was really more of a classification. So things like that.
Yeah.
It was a conversation you were part of. The 3 of us were there.
Yeah, and like year is a yeah, you were there.
I was thinking about hyperdimensions, sorry.
Separate bill. That makes sense.
Yeah, and so I'm just gonna leave all these tree options. It does like, this is I was talking about how you want validation sets for tuning your hyperparameters. These are the hyperparameters. We're not doing that today. That's a topic for another class. We're just gonna assume that the hyperparameters are all pretty good, and we're just gonna try it, see what happens. So we got this thing, and we're gonna say, learn it. It learned it. Now what?
We're done.
It understands. Well, we have no idea if it's any good, right? So now we got to figure out if it's good. Well, now we need something that we need to actually run this model on data it hasn't seen before and evaluate it. So let's just so we have the learner. Now we have a predictor. And we can just feed the model that it produced into the predictor. And then we're going to take this 30% of our data that came out of the partitioner, feed that into the predictor, and we're going to output data. Oh, we're going to execute it first. Execute. And then we're going to look at the output data. And so we'll see that there was some value. Looks like this first one. The actual value was 140,000. It guessed that it would sell for 178. The next one was 345,000. It guessed that it would sell for 346. That's pretty good, considering we did jack for actually optimizing this thing. This was a terrible algorithm, and yet it still worked. So let's actually evaluate this. Like, how do we evaluate it? Well, we can just take our scorer. Literally just type in score, and there is a numeric scorer. We can throw that in. feed the result into that, and we want it to compare the actual sale price with our predicted sale price. And then let's see what happened. Oops. Execute. Oh, wait. No, I want to reset. I want to execute and open views. So, 10%. This thing can predict a house's price accurate to an average of 10%.
Do any realtors around here use?
I don't know, ask her.
No.
No.
Well, I have a small office, so these are the bigger offices. They might now. Well, I'm sure they have people trying to figure that out, but it's tough because
You gotta
you
get the
really
data.
need to do the things like you're talking about, the neighborhood because, or even like the city because
Yeah,
you may
'cause-
think, oh yeah, there's a 3-bedroom, 2-bath, you know, it's got all these amenities, blah, 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 but it's on a busy street, so, yeah. not
Yeah.
so
In this
self-reflective.
area, you can almost go in like block by block for some parts of Medford.
Yeah, or,
Yeah,
yeah, it's
and
not good, but it's got a crack house.
Right.
You know, whatever, you know, you don't know. There's,
yeah, and that's all information that you can gather, and that's part of. So when I initially show, that's why I always want to talk about like, when we talk about our data science, the actual algorithm choice that we used and how that works, that's the machine learning. But what she's talking about, is it close to, is it on a busy street? Is it what all these other questions she's asking?
crime statistics.
Yeah.
Like feed those in and say,
Yeah.
let's see how many, and what kind of crime? Is it like this, oh, there was some larceny, whatever, or was it like major, like, because they rate those too?
So that's
Yeah.
a really good example. You take that machine learning, which is the
Yeah.
algorithm, and combine it with her domain knowledge.
Yeah,
And, you get your
and so here's the interesting thing is that algorithm I threw it together, got like 10% accuracy. The guys that are winning this competition, I mean, they've been doing it for years, they've tweaked their algorithm over the course of months or years even, but they're getting accuracies like less than 1% accurate, or like in terms of error. Like,
So they're not just using these built-in algorithms that you can just drag and drop. They're actually writing their own and optimizing
well,
their own. And
so this is why I'm introducing KNIME because I feel like KNIME is fantastic for the exploration phase. Every data analysis should have multiple phases, and one of them should be exploration. The actual tuning and actual optimization, trying to shave off every little bit of accuracy you can get, that is a whole other phase that really takes a lot of knowledge and resources and stuff. Those are the high-paid data scientists and machine learning engineers that are getting paid to do that, and then combining their resources with some people who are, experts in whatever domain they're analyzing.
If you were to ham fist just the 30,000 foot view of like what you would go do from there to actually start to optimize, what would that start with?
I have a precursor question for that. Since KNIME is open source, can you see the algorithms, the code behind the actual nodes?
Yeah.
Yeah.
Yes.
Starting place if you're going from KNIME.
Yeah, and a lot of these algorithms, so when I implement, some sort of regression system or classifier in KNIME, a lot of times it's actually using like maybe a scikit-learn module. So scikit-learn is like a library you would use to actually program this stuff, and they've packaged it into an easily editable node. So that way you can, if you want to, you can be like, oh, you know what? I really like their deep learning network, but I really want to modify their activation function and change their backpropagation algorithm to do. You can do whatever you want. But if you're going that far, yeah, there's a lot you can do with stuff, and KNIME is really the starting point, I feel like. But you can do even hyperparameter optimization and stuff like that in KNIME using flow variables. And they have a lot of ensemble learning systems and stuff that you can use to combine multiple learners into one. And that's really one stage that you would typically see people go. As he was saying, next stage of development is try different well, that would probably be a couple steps ahead. The next step I would do on this is start classifying those strings, break them up into separate fields, home types, whatever. I might even do GIS, like look up stuff, like do some sort of address to GPS thing to try to determine the relative nature of these things. And I may also like include like some sort of kth nearest neighbor component, and then combine the results.
So like they've used public health data at this sort of neighborhood level to look at life expectancies, right?
Mhm.
So they're taking into account like educational opportunities, like all of that stuff. So it would be based off of something kind of like this that they got to that.
You're saying, so you're saying how did they get this data? Or what do you?
No, I mean, I'm just trying, because this is so far outside of anything that I ever do. But I'm trying to figure out, like, I'm trying to make a connection to the things that I know and like, how this presents. Like,
So you're asking, how are people in your field determining life expectancy from all of the other stuff they know about people, like neighborhood information?
And even some of that is coming out of like ME data, like medical examiner data, just stuff like that. But
So I mean, if we got to talk about what sort of problems you're trying to solve, and what sort of data is available, and then we can really address each problem individually, because there's ways of analyzing data for all sorts of different problems. Like if you're trying to say, like, hey, all these people have this group of people have a life expectancy shorter than the rest of the people, and we have no idea why. That may be a clustering algorithm that you want to run.
well, and it seems like this stuff is really limited by the fact that when we're looking at some of this sort of public health case data, it's really these smaller clusters. So you're saying like some of this stuff needs to be in excess of 50 data points.
In order to learn the model. In order to try to figure out what the trends are, you're not going to find trends with just a few data points. But if you have access to large amounts of data, you can find like correlations between things. You can find patterns. You can find, you may realize like if you plot people's addresses and then convert that to GPS and then add it to a database with life expectancy, you might go, holy crap, everybody who lives in this area has 10 years shorter life expectancy. What the heck is going on there? Like,
Well, I mean,
Love canal.
applications of like epidemiological data and sort of, like if we look at like orchards, like the historical data for orchards and applications of different pesticides and what they were harvesting, and then seeing like what is the actual like, income outcomes for that community, right? So we see like lower earning potential, and that leads to poorer health outcomes because of the way poverty is linked to.
yeah.
I think a lot of that comes to, so that pyramid that you showed earlier, a lot of that is that big base of the pyramid.
Yeah.
And that's that piece of data science of where you talk about how we're collecting data, how you're correlating data with other data. So you have some collected data here, you have other collected data here. Is it even appropriate to try to combine that data? The whole field at that base of that pyramid is what you're describing, that problem and the solutions that they try to generate. Do you collect data? Do you survey people? Is that going to be appropriate?
Yeah.
Or do you try to get some anonymized data dumped from somewhere else? Do you use public data sets?
Yeah.
That's the big part of the
There's
question.
crappy
That's
data,
the,
there's-
would that be the?
Like, what'd you have for dinner like 5 weeks ago?
Yeah, and there is a huge problem with data quality, and data set, the way that data is collected. Because if you, just in real estate alone, there may be a score of like slope, like the slope of the property, and so it's like somebody may just be like not very sloped. But then somebody else may go out there and just be like, what? I can't even build on this property because it's like this. Like, so it's like there's all sorts of subjective information that gets added to these and stuff. But what I find the most interesting about it is despite the fact that like half of this information is subjective, these guys are still able to predict the selling price of this within like 1%. So it's like there is enough data there to know what's going on. which is really cool. So if you know how to analyze it and want to take the time to really pick it apart and discuss all the pieces of it. So, yeah, what's up?
You said that wasn't a very good algorithm, or that wasn't a very good model. You used like 12 different inputs and a whole bunch of different ones.
Yeah, but I didn't even look at I didn't even look at them. I just said, oh, this is, oh, well, here's a bunch of integer values and stuff. So, scores, I don't know what this is, but I just threw it all in.
What's it using, neural net or?
So this system, this is a whole, this is an ensemble regressor. It's a whole other discussion we'll probably have to have later.
20 words, what's an ensemble regressor?
So essentially the idea is you have a machine, I'm already out of words. No, I'll try to do it in 20 seconds. How's that sound? I can't count my words. Basically, you have different machine learning algorithms, like regression finders, and you can actually do lots of them, and then combine the results of them in some sort of meaningful way. This is a system that uses lots of regression, and it uses a decision tree combiner. Yeah, it follows something called gradient boosting, and it's a whole cool thing that is not a topic for today.
So if you're to change the gradient, the tree levels from 4 to like 12, would that make it more accurate?
That's a good question. So like the depth. So you want this all the way up to.
I assume higher is going to take longer.
You would think. Let's see how long it takes to do 12. Let's see if my computer crashes. Nope. Easy peasy. So let's see how it scores.
Do you have to do the one in the middle?
No, it got worse.
Oh, what?
Yeah. And so, which is weird because you'd think like, hey, it's like searching for more solutions. And that's a whole discussion of overfitting, which is a word that I can't believe I haven't said yet today. Because if you take a machine learning class and the teacher asks you, why did we add this function here? You have a 90% chance of being right if you say overfitting.
What if you do 3?
Well, let's do 2.
So when you raised it up, your R squared score actually got better.
Oops.
But the other one went down.
Yeah.
It was worse.
And so that's because R squared is the correlation coefficient, and we're going to have to end things pretty soon. We can keep talking about some of this stuff later.
Do you want to talk about administrative stuff?
So that's pretty similar.
Actually run out of time.
Really didn't change much. But anyway, so now that we have this, I gotta say this real quick. Now if we actually wanted to test this, I need to read, if I want to actually submit something into this competition, they want me to grade their test set that had their unlabeled data. I need to add labels to it. So I need to take that, and I'm not going to do partitioning. I'm going to actually just take all this. Well, actually, there's really no way of scoring because I don't have labels. And then, yeah, isn't it awesome? It's you spend so much time programming this in your classes, and then but they never tell you about this tool. That's why I said this sort of thing and these cheat sheets and stuff, they're like the best kept secrets. They want everybody to do stuff the hard way. Yeah, so I'm going to label this. Actually, no, sorry. I am not learning from that because that's the unlabeled data. I need to learn from the labeled data. But before I was learning off of 70% of the labeled data, I want to learn off of 100% of it now because why not get a little bit of extra data in there? So instead of running it through the partitioner, we'll just read all of the data into the learner. We have no way of evaluating it, but we know that with these parameters, it gets fairly good results. So what we can do is we can just go ahead and just leave all the parameters the same, don't run it through the partitioner, feed all of your known labeled data into it, so that way you have a model that you know works good combined with the largest data set possible. That's what you want. And so then produce a model from that, feed that into the predictor, and then execute, output data. And so there was no sale data. Now there is. We have sale data now.
Let's submit it.
I actually submitted this.
Score that back.
Like because I actually cranked this out during my lunch break at work. I'm like, I'm gonna just analyze a Kaggle set, and I just downloaded it all real quick. I did this all in an hour real quick, and then I just uploaded it, and I scored better than half of the people in the competition. Like, so that's in like 1 hour of cranking it out. So it's like, and I did nothing. Like,
That's how good most people are at data science.
yeah, and then.
How much easier KNIME makes things.
Yep. And then what you can do is you can just say filter. You take a column filter. You feed that right there. We want to take out everything except for, hold on.
What about the steps for normalizing each value to like between 0 and 1 and whatnot?
Yeah, that's a whole other discussion. Normalization is something that I was talking about, is important. So normally you would want to, so for like year data, that's a good one that you would want to do like max min normalization. So that way it's all like, just turn it into a number that's equally distributed along between 0 and 1. And then that would be good for like year data. And then something else, like let's say like you had some other like square footage or something. Square footage is probably normally distributed instead of equally distributed. So that you wouldn't want to do min-max normalization. You'd want to do like z-score normalization.
Is it safe to say you should pretty much normalize everything?
Yeah, but you need to normalize with reference to what the underlying data is. So like I was just saying, like price is a normal distribution, probably.
Right.
So that you would want to use like a z-score normalizer. So that's going to create the most even distribution to make your gradient most easily climbable.
So are you basically differentiating or bucketing z-scores and normal distribution versus equal distribution? Is that?
Yeah, so like min-max normalization would be what you'd want to use for like an even distribution.
Okay.
And then as far as like the other normalization for outputs and stuff, that's more of a problem of a classification thing. But for regressors, we actually get a value out.
The normalizing happens before the
So
booster. Gradient
we do normal in this. Yeah, we are normal. We would want to normalize the data. We didn't, and we still got good results. We got 10% accuracy. Like, I mean, that's pretty good considering we didn't do anything.
I don't even know what we put in there.
I know. We literally just threw in a bunch of random values.
All the integers.
Yeah, just take all the integers, put in integers in. We did zero domain analysis.
The old ideas to it.
And so this is one of the things I think would be cool in the future of this club is not just have classes that are about the algorithms and stuff, but have people who know the data, you know, the public health data, the real estate data, the health data, and just talk to us about what, and just say like, what are the problems we have in the community and what is the data that's available to try to analyze it. You know, those are the types of things that I would love to see happen in this club.
When it's cold.
Do stuff like sentiment analysis and
What's that?
like sentiment analysis.
Yeah, so I do sentiment analysis in like in some of my financial stuff, and because there's people that actually do sentiment scoring, scores for you on stuff, and you can like look those up through various different resources, depending on your data. There's all sorts of stuff, and like there's all sorts of AI stuff for trying to derive sentiment out of data too. That's a whole other thing.
I literally just talk to like two people.
Yeah, honestly, I feel like there's so much that can be learned just from these sort of dumb, sloppy techniques that isn't being taken advantage of in so many different domains, that it's like, if I could just get people doing this more, like maybe some of that low-hanging fruit and stuff, like the problems that are easy to solve, maybe we'd find them if people just did just this. Like,
This is an executive level effort. I mean, even the big guys will
Oh yeah.
put this much effort into it.
yeah. But yeah, anyway, what I was doing here is,
It just has to have a PowerPoint that goes along with it. Then you're golden.
take out the row
Does
headers.
this export to
Yeah,
a
is there export to
Python?
PowerPoint? Is there a PowerPoint dev?
No.
It should just
suggest
auto-generate.
that to-
Well, I know.
Well, that's the thing is there's
What we're doing for activity.
there's customizable nodes. You can make your own node. You can.
Software that wraps this into some like crazy.
So there's actually like JavaScript presentation libraries and stuff,
Yeah.
but I don't think there's a PPT output.
Is there like visualization outputs?
Yeah,
Board deck.
there's actually a whole bunch of visualizers.
Yeah,
So
there's like a D,
um,
like a D3 node or something.
you know, like one thing we might look at, like I was saying, is
Can you export the model itself, not the outputs of the model, but the model?
I think these ones will let you. Gradient boosting model, learn spec. So yeah, it basically goes through, it defines all the arrays and what they're full of and stuff. And so if you want to write a system that interprets this model, you can output it. I'm guessing it can output to JSON or something if you have an interpreter of some kind.
Can it output to something that you can use in scikit-learn or Keras?
That's what I'm guessing. I haven't messed with pulling models out for other applications, but I'm sure you can.
Do you know anything about like generating a variety of models and then comparing the models to each other to see if?
Yeah,
like
that's kind of what that. Well, that's kind of what I was talking about with the high. Well, okay, so you're talking about using something other than like this particular.
Well, 'cause, like, right now we just took all the integers, put them in there.
Yeah.
But like if we can have a machine say pick 6 different things and in parallel have a bunch of them pick 6 different things, and then you can find without having to manually go through all the different integers that we went through, and they could find stronger correlations perhaps.
I mean, you could probably write a script that'll go through and like. You're saying like find the integer fields and group like figure out the distributions and determine how to normalize them and all that stuff for you, or what are you talking
just
about?
like brute force trial the combinations.
Yeah, something
so-
that can just literally just
Yeah.
experiment, randomize, and
Well,
figure
and
out.
see, and that's kind of the computer scientist approach, and that's will always be limited. Like, and that's
Well, this is the exploratory phase.
yeah, exploratory phase is great.
Not something that can apply machine learning to machine learning.
Right.
Yeah, and that's really what ensemble systems are.
There's a classifier comparison, and what it does is you input different models, and for those models you have different parameters, and you can pass ranges within each of those parameters.
Yeah,
And so you can create a model to evaluate like 6 models using 18 different dimensions.
yeah. And one really popular way is to use what they call a perceptron, which is essentially a single digital neuron, where each of your models are hooked up to a different input of the neuron, and then have it evaluate stuff, and then it compares the predictions, and it basically will weight the accuracy of the models that are going into it, and that's one method of doing ensemble learning.
That's what I was saying.
The last
Okay.
one is that like all
Using
the
correct terminology.
Yeah, you're basically talking about a perceptron-driven ensemble learner.
Perceptron-driven ensemble. That's $1 million phrase.
Right there, Perceptron. It's like an easy-
A lot of ensemble learners, are kind of perceptron focused.
Perceptron what?
You're basically an ensemble.
That would be
It's a perceptron ensemble.
We're a perceptron-driven ensemble. Thanks for
Yeah.
We'll be our night.
See if Johnny B's next week.
Okay, cool.
We'll be joined by gradient descent.
Perceptron.
Did you find it?
Words.
So filter, CSV, and now we're going to do a CSV writer. We're just going to write to my desktop. It says results. I don't care. Yes, I do. Dang it.
Couldn't do it.
I can do it. I'm like, I'm going to hit save. I don't even care.
You tried. You tried.
Lies.
Yep. So it says it did something. Let's go look. Hey, look, results.
Result file.
Oh, snap!
Whoa.
And we just beat half of Kaggle.
Science.
And so that is the main presentation. So I figure, is there any specific presentation questions that we wanted to address before we start talking about the future of this club?
That was the sexy part. You said the stuff he was talking about earlier wasn't sexy. I was just making sure.
Yeah, that was the sexy part.
Sorry. Out of my element.
Yeah, you're not invited anymore?
Those numbers.
Yeah.
It's beautiful.
See, as you go up that pyramid, that's where the pay scale starts going up.
Yeah. Yeah, see, the guys down below, they're making like a measly like $50,000 a year. The guys up there are making $200.
Like write numbers down one by one. That's a terrible job.
Yeah.
You don't want that.
That extra $150,000 is pretty sexy.
So, when you're up here, you say, "Hey, I need this," and it goes down the hill.
In the wrong field.
Well, the right field's right there. Right in front.
Well, within 10% error.
All right.
Here.
Well, cool. Did anybody think about any of these questions? Like topics they'd like to see covered in the future, how often they would like to see this club meet, maybe like if you guys have any topics that you feel like you could contribute to a program like this and teach.
We
And
should know we have a huge parts store and oscilloscopes and power supplies and servos and 3D printers and
oh yeah, anybody who wants a tour of the place, this is like a full-blown like hack lab, pretty much, is what we're starting. So
we just have a lot
we
have
got
a lot of gear.
electronic, yeah, a ton of gear. We got a server room and all that stuff. So
So how many of us actually have any experience doing this? You so like
I've knocked around.
you don't.
you don't count. I know how much you
Walked
don't.
around.
Like the 3 years. So I would say even something like just like what we just did, this kind of collaborative problem solving, where even the people who aren't very comfortable with it, like I can stand up there and do what Cody just did, but talk about it and make it like kind of a group effort of, hey, here's this cool data set I found. Let's see what we can do with
We
it.
should
Yeah.
solve
So that'd be
it.
kind of
And there's also, the potential for doing like research, like if you're wanting to like learn, like, you know what, how does a neural network work? And I found that sometimes the best way to understand how something works is to sign up to give a presentation on it.
By what you did, I only meant the NIME.
Yeah, but I mean, if you want, but what I'm saying though, if you want to understand neural networks, the best way to understand neural networks is to just sign up to teach everybody about neural networks. You'd be surprised how much you'd learn. You'll learn more studying for that presentation than you would in a class.
Is that what you did here? We were trying
Yeah, I've never actually done any data science before, so no.
That's true.
Had a name.
We figured this out today, actually. I mean, we were
Yeah, I actually did write this presentation today, so.
we planned the class, and then he was like, "Oh, I have to figure it out."
Sent out an invite. I was kidding.
Yeah.
Yeah, I sent out the invite. I'm like, if a bunch of people decide to show up, and I'll see what what sort of backgrounds they have, and then I'll write a presentation based on what they want to know, like what I think they'll like.
Identify someone who's a procrastinator. They'll set the deadline so they have to do it.
I totally
It-
did that.
That's how you get things done.
That's the best way to do it.
Okay.
Probably run it.
And the other thing too is I thought because if I'm the only one teaching, there's no way this is happening once a week or every other week or at most once a month.
And you
Like
don't
if
want
I
me teaching.
and so basically if we want something like this to happen frequently, people gotta volunteer to do something. And then the other thing I was thinking too is maybe possibly what if we did a lesson once a month, and then maybe the first Friday of each month we'll do a lesson, and then the third Friday of every month we'll get together and actually just do a Kaggle competition or something. together.
Hang out, work on data.
Yeah, just hang out and work on data science for the evening.
I like that, 50-50.
Yeah, I thought that'd be kind of cool.
Bring your own beer.
Yeah.
Sorry, I didn't have time to get beer today. I totally
Yeah.
would have. But
Or pizzas. I was even gonna pay
I
for
was
it.
gonna get. You're gonna be disappointed here, so I was gonna get pizzas and beer.
Why would you share that? Like, Justin doesn't know everyone in the room.
I'm gonna do it next time.
That's how you get
So
people
if you
coming
come back again,
Then I
he's
get beer.
So I think they're looking for volunteers to coordinate that effort.
Yeah.
They'll give you the money.
I mean, I'll coordinate Josh buying beer.
That's half the problem.
I do have wine. If you want wine.
Yeah.
I do have wine. In plastic cups. Oh, I forgot the plastic cups.
I am down to learn things and then present them a couple days later. I don't know how formal that'll be, but I'm
It
happy
doesn't.
to read.
I mean, this is a pretty laid back deal. Like, you know, who know? It doesn't have to be that
We're gonna kind of wing
formal.
it.
Kevin's a very good teacher. He can learn things and teach them.
Definitely wants.
Did you say?
You gotta do modular synthesis for one.
No, I get embarrassed in front of crowds.
You really?
No.
No.
No. It's like, stop looking at me.
We'll just put AR gog. You can do it in VR, and that way it's just a virtual environment.
Yeah, it's a video game.
It's a video game. Sound like a
You're
VR
like,
person.
It's just a
Just a camera.
an Oculus with a camera on it. This is for presentation anxiety.
Those emojis, yeah, or whatever, just there.
In VR,
Me
we're all sitting
emojis
around
in
the table,
VR,
but in
yes.
real life, we're
Exactly,
all sitting
we're
around
all
the
sitting-
table.
Is Karen still in the room?
I think you lost her. You're down to one attendee.
Who's there?
I don't know. Attendees.
Oh, did we have more than one?
cardboard
You had
glasses.
two for a minute.
Hey, attendee, identify yourself in the.
NADSS stream. So I think it's just.
Oh, that's us. Oh, so there's nobody even watching remotely now.
I think Karen Alport left.
How long ago?
At least 10 minutes ago.
Oh, okay. So she watched most of it though. Oh, cool.
I make no promises
Up
about
to a minute.
accuracy of my statements.
Okay.
In a 20% margin of error.
Okay.
What are your other two questions?
Oh, sorry. So the first one was, how often would you like this group to meet? And then, do you have a topic you'd like to teach? Is there something specific that you would like to learn? And the last one is, would you like to participate in a group development project or competition?
Does Friday work best for everyone? General?
Yeah.
Friday.
Yeah.
Cool.
I don't. Yeah, I hate Thursdays because
6 o'clock was perfect.
it seems like every programming group they want to do first Thursday of every
And
month.
that way we can turn it into.
The Hack Lab used to do it. The Soggy.
Second Thursday now.
Oh, Hack Lab's second Thursday now.
Because the radio club's first Thursday.
I know that was the thing. The Radio Club's first Thursday. Soggy Group was first Thursday. The
Soccer group still is first. Are they still doing it?
yeah, and then like the Rogue Tech Hub is like kind of the Soggy Group, but also its own separate thing now, and like it's just weird.
All right. So what's Soggy Group?
Southern Oregon Geek Group. But it was really popular like 5 years ago, and then like I left the area and came back, and like half the people that were like really making it alive, like they took off to Portland, and yeah, kind of
We're trying to get
not as many
back
people.
here, out of those areas.
Yeah.
Trying to turn this into.
Anyone learn about learning with LSTM or long-term, short-term?
Yeah, so that's a cool thing especially for like time series systems and stuff. It's because
Any sequential
Yeah.
things that come in?
anything with sequence, long short-term memory. It's basically a neural network that you can actually feed in a sequence of data, and it actually learns the patterns of the sequence,
So
which is
did
really
you
cool.
volunteer to teach that?
I was gonna say, sounds like a cool topic.
Yeah.
Pretty cool.
Okay. So, well, you don't have to stand up and volunteer right now. At least just like come and talk to me or Josh if you want.
All right, I'll teach the next day.
Is there any topics that you would like to learn? Like
No,
I kind of rushed through a lot of stuff there, and I don't know if anybody was like, wow, I really want to know what the heck that was about or
We
something.
just picked data science as the anchor point because you can pretty much apply data science to everything. So we'll probably find a way to like bring it back in some form. But
Yeah, I feel like most of the computer groups and stuff though are so obsessed with like like Arduinos and 3D printers anymore and stuff that it's like they don't get into the deep mathy stuff anymore.
I mean, we can definitely do some of that stuff. Like I would love to do one on just like audio engineering.
Yeah.
For instance, like all the like really deep stuff.
You do like FFTs or something?
Yeah, we could do.
Because that's a signal processing thing. That's
spectrography or
Yeah.
any of that.
You could find out where audio engineering and data science
Data
overlap
science.
and do your presentation on that.
Exactly.
There you go.
That's what I'll mix into it. I'll give the data science spin.
It'd be cool.
Well, actually, would be kind of cool.
Any
There's
industry
some audio
with data
stuff
science.
in
me to
KNIME.
identify like good patterns in
I mean,
in
that's what would
electronic
be.
music
It'd
and
be kind of
I was
interesting.
thinking about that for
We
a long
could
time,
come
actually.
up with the
The
next
melody writer.
pop song.
top hit, like number one.
You probably
you can use an LSTM to listen to a song and then tell it if it was a hit or not,
Star.
We can carry
and then see if the LSTM can
Where it was
find
on
if a
the
hot
charts,
yeah.
how much money
Wait,
it
go to Kaggle real quick and check to see
I
if
think
there's
that's
any
why Ed Sheeran
audio
is
or
on
song
right
data
now,
sets.
actually.
They've already done that.
I'm curious.
Yeah, because he stole a lot of people's music.
It was worth it.
I mean, he looks like a fish. So.
Or even, not even, it doesn't even have to be competitions necessarily. It could be.
Oops. Well, you can get your own data set, right?
Audio
Tagging.
Audio tagging challenge. That's kind of cool.
Recognizing sounds from nature. That's pretty neat. Bird challenge.
Bird challenge. That might be fun. A good one for because you used to do dog barks.
Oh yeah.
This would be a good one for you.
Oh, do
I
that
used to
one.
be the best dog bark imitator ever.
Let's see how you
Do
can
it.
try.
I worked at a company that made like dog bark stopping products. So they had ultrasonic and audio transducers. But we also had a pest repeller line that emulated like cougar and mountain lion sounds to scare off
Yeah.
wildlife. It's really
Saw
interesting.
the one that was like whale identification on here.
Oh yeah.
Oh,
What?
to identify what whales are saying?
Yeah, I mean,
Yeah.
I used to do some actual bioacoustics work. I guess.
Sentiment analysis.
I want a
Sounds.
presentation on that. I'm
Alright.
volunteering you.
Volunteering.
Voluntold.
Voluntold.
Whale detection.
The Maui Ocean Center used to have this little station that was mostly for kids where you could play different whale sounds and you had to guess which whale it was. But there were only like 4 of them, so you got really good at it eventually. It was neat.
Funny.
Hmm.
Score.
Yeah. So these are the guys that.
So what is this? What is this one?
This is detecting a whale call.
$10,000.
If you can.
Club
It
donation.
says
You could bring in some really cool speakers with $10,000 though.
Oh,
bring in, like-
I've got plenty of speakers.
Yeah? Are they all?
I need money to
yeah. This one's already ended.
A what server?
This is an old one, but you can still try it.
Just for the fun of it.
But it looks like these guys won. They got something that could predict whether or not it was a whale or something within a couple
Or which
percent. So,
whale, maybe.
yeah. Like,
I mean, I can tell you whether or not something's a whale.
can you?
Likely, yeah.
At
Listen,
least within.
Just by an audio file?
I mean, I could probably get close. You can test me next time. I'll make an idiot of myself.
Can you write a program that can do it though?
It could be a fun project.
Because if you can,
already.
there we go.
There we go. Do that and then present, and you can poke holes in it.
You can make a team in Kaggle.
Yeah, so that's actually what's cool about this is like if we work together, like if there's some of us that are more experienced than others, that's a great opportunity for you to kind of get some clout as a developer because, you know, if you're a team and
Yeah.
like you can write off of other people's knowledge and
This is one of the main things you're interested in, right?
it's really good for
Do you have
networking.
anything specific within machine learning that you guys wanted to dive into?
I'm pretty green as far as like the whole concept. As much as I've touched machine learning has just been just writing in Python and trying to follow some like Google based tutorials and learning or YouTube based tutorials
Yeah.
and learning.
What
I'm
have you done?
super stoked about. I'm a stupidly competitive person, so this
Yeah.
speaks to me.
Yeah, and this would be great, especially as a team and stuff. If you're trying to if you want to work in this field, working as a team is a good way to get your numbers up there.
Yeah.
So I'm guessing the answer to the last question is yes.
Yes.
Yeah. 'Cause I'm
For
down
me-
That seems to be the
Yeah.
What do you guys do for communication? Like, set up your own Slack or make some-
Karen mentioned that she might be willing to do something, maybe do a presentation sometime.
Yeah. I mean, it's all public health stuff, so it
That's
gets it gets really bleak really fast, especially in the Rogue Valley.
Well, that's
I don't
That's
know,
good.
Are we naturally fascinated by things that are kind of dark? Isn't that like a human trait?
I mean, I want to, assess you for suicidality and figure out how to hang out. I'll try to end on a positive note.
because I feel like those problems, I feel like people who are into data science are the types of people who want to change the industry or change the world, sort of types of mentalities. We want to look at problems that are really hard to solve and deal with them. And I feel like if you have problems that even if you don't know the solutions, if you say these are problems in public health and this is the data that might help us find the solutions, that could get, people excited around here.
Yeah, so even if I just did an overview of the big community health assessment that I worked on, and we developed a community health improvement plan, so looking at the data that's available and how we're looking at it to try to.
It would be kind of cool to use, because that's data we can use that's immediately applicable for real world case. I kind of wish I could just look these data and be like, let's use it here.
None of mine's proprietary. So
Perfect. So that's,
you want to solve intergenerational poverty? Let's do this.
yeah.
I mean, if you did a just overview presentation, could even follow it up with a brainstorming session of, hey, this kind of data seems like what we would need to solve this kind of
Well,
problem.
it seems like the right kind of data set where we would have to solve nuanced aspects of each of the parts of the pyramid too, right? It wouldn't just be one dimensional. It'd be we'd really have to go through the whole scope of something.
Yeah, I mean, another format too is you don't have to present for an hour. You could present for 20 minutes and then open it up for just a group discussion of how to solve it, and we could just maybe brainstorm stuff or something. I feel like there's a lot of smart people in this room that.
Okay. I am going to Baltimore for a data conference, so I'll see you.
Nice.
That's cool.
Nice.
So what you're saying, do you think Slack makes the most sense? Is it the easiest for communication?
Well, Rogue
really
Valley
like
already has stuff set up, so you just making channels in there. I mean, the more we bifurcate, the more that creates segregation. There's not a lot of
You could just make a NADSS hashtag in the Rogue Slack probably,
Yeah.
or the Hack Lab Slack.
I mean, if you're not trying to
No.
start your own
Nah.
thing, if that's the case, then
She thinks it's hilarious.
Go nuts.
Yeah, go net, go Nets.
Go Nats.
Sorry.
That took me a minute. That took me longer than it should.
Wow.
So in case people didn't realize, the entire name is a joke.
What better way
Like-
to
But
get people in
the
data
important part
science?
is that you know it's a joke.
Yeah, I mean, we're should we be like the Southern Oregon data scientists and yeah, the SODs?
it'd be even funnier if we
Yeah.
pretend like we don't get it.
And then someone pointed out that SOD is actually short for sodomizer. I didn't realize that. Yeah.
Or dirt
So,
mixed with grass.
Also
Yeah.
that. That's what I meant.
well, SODs as in a person, but yeah.
Yeah. Well, I mean, then
Yeah.
you can get into some
But I'm
other
like, why are we even just Southern Oregon anyway? Let's just go International Society of Information Scientists. But apparently ISIS is already taken. So we're just okay. Well, how about North American Data Science Society? And then it sounds continental. It's cool, and we're not, which is funny, and it spells
It's
NADS.
kind of like dressing for the job you want, though.
Uh-huh.
You're
Exactly.
getting paid for the
That's why we got a really cool logo.
I know.
And that's why we're
That's why
gonna.
Cody's
I'm gonna
in
build
his
it.
best attire.
I'm gonna build an animated splash screen
His best
for
creation.
nerds. And
You like the logo, by the way? I cranked that out on my lunch break too.
oh, yeah, no, it's good.
We're gonna look all official.
So prepared in advance.
Well, thank you for coming, everybody.
Yeah.
Thank you.
Yes.
But feel free to hang out. Anybody who it's not like you have to go home or anything. We hang out and talk until whenever.
Yes,
So
it's true.
Until bedtime.
until bedtime.
I do have wine.
It's Friday. That's the nice thing about doing this on Friday nights is we got nowhere to be tomorrow, so we can stay up till whenever, talking tech. So, but all you people who want to get out of here, have a good one.
Yes.
Hey, thanks for coming.
Show,
Alright, cool.